Good afternoon, everybody. Hope you're having a good time here at Blackhat. This is the reverse engineering track. This talk is The Bluescreen of Death is Dead. Your presenter is Matthieu Suiche, memory expert, who would like you to know that he has just turned 21 and will gladly accept donations or drinks after his presentation. Without further ado.
Nice one. Just bring me a beer, that's enough. Okay, so to introduce me, I'm the founder of a company called Moonsols. As you can recognize in my accent, I am French, so my company is based in France. You can also contact me on Twitter if you want. I'm a Microsoft MVP, and I've done a lot of various works regarding the Windows physical memory, not only on Windows, also on Mac OS X. So we will see in this talk every works I've done related to Windows physical memory. So what kind of people are really interested into memory dumps? So it's really easy. Please raise your hand if you have never used a crash dump, even a core dump. This is ready? Oh. The crash dump is the Windows name for core dump. So in fact, this is exactly the same thing. So in this talk, we are only going to talk about full memory crash dump, so full memory core dump if you want, if you prefer. So memory dumps interest only kernel developers. When they have a bug in their driver, they got a crash dump, so they can analyze and retrieve the bug. Same thing for kernel troubleshooters. People who are looking for bugs, investigators, forensic experts, malware analysts, and people doing incident response. So why they are interested in memory crash dump? So it's really easy. For instance, you have the bug hunter. As you can see, it can be a man who just wrote a fuzzer in Python, like 10 lines. Actually, it was a friend who found a remote bug in SMB. So he was like, I just wrote a very tiny fuzzer. I got a remote BSOD. So just take a look at the crash dump. So this is the real life case. Of course, you have the kernel developers. If you do some kernel development, you know it's really boring. When you have a segmentation fault because your whole machine crashed, so it's really a pain to troubleshoot. And one of the most common is null pointer. You also have people with a different profile, investigator and forensic expert, who are looking at the memory to extract information. So let's say there is the inspector gadget who just made a memory dump of the Dr. Cloud computer, and you want to retrieve various information regarding Dr. Cloud. So like his Facebook or web activity. You can also retrieve the server where the Dr. Cloud was connected to. So let's say porn server or whatever. So it's also used by malware analysts. If you are too lazy to unpack, for let's say a driver, you can still use a memory dump, so you can still extract the image of the driver from the memory. And for instance, on Windows 7 64-bit, we can no longer use soft ICE, so it's really sad. So we need to find an alternative way. Microsoft has its own kernel debugger, which is Windows debugger. So it supports kernel debugging and crash dump analysis, so it's really great. And of course, people doing incident response, let's say a machine just opened a PDF file, you didn't have time to get a copy of the file or one of the executable downloaded by the shellcode. Or let's say the executable downloaded by the shellcode had been removed from the server, but you have a memory snapshot of the target machine. You can still analyze the memory dump to retrieve the timeline of the attack. You can also retrieve the shellcode in memory, the PDF file used for the exploitation, and also the executable downloaded by the shellcode. So let's say you want to retrieve a memory of shellcode who is using hipspray, so it can be really easy because most of the time when you see an hipspray shellcode, there are really a lot of nup opcodes. So it's always it's a static signature you can easily retrieve from the memory. So this talk is only focused on software acquisition, on software conversion, of course. So regarding the physical memory, there on Windows we have 4 main kinds of memory snapshot. The first one is the raw dump, when you want to access directly to the device physical memory. But you can only generate this kind of file by using third-party tools. The second way to get a memory dump on Windows is to use the hibernation file. It's present on Windows since Windows 2000, so you don't really need to install extra tools. And the third one is the Microsoft crash dump generated by the Bluescreen of diff. This one has a notable advantage. When you have a Microsoft crash dump, you can analyze it with Windows Debugger, which is not the case of a raw dump or an hibernation file. Or even if you have a server with Hyper-V or VMware, the physical memory is saved on disk when you are pausing the virtual machine. But you cannot analyze this memory snapshot with Windows Debugger. There are also physical way to access to the physical memory, of course. This thing had been already covered many times by a lot of people, so I'm not going to talk about this. Of course, you have the DMA access for the direct memory access by using the FireWire, the PCM, CIA, etc., etc. If you want to learn more about the physical attack or physical acquisition, I suggest you to refer to the VirtDBG talk of Damien Aumetre and Christophe Divine. Using an FPGA over a card bus, they are able to access to the physical memory, and they wrote their own debugger. So it's interesting to see how to access to the physical memory by using DMA access. But as I said, in this talk, I'm only going to talk about software-wise. The thing with software acquisition of the physical memory is you don't need to have any specific hardware, so it's way more easy. Yeah, unless you have a very unstable machine, but the only driver who are really unstable are the NVIDIA drivers, so it's okay because we are not NVIDIA. With the software acquisition, we can retrieve the memory snapshot, for instance, with the hibernation file. The hibernation file is generated by Windows and it's never wiped. So even when we resume the machine, we still have a copy of the hibernation file. So we still have so in any case, we still have a way to retrieve snapshot of the physical memory, even if we don't run a specific software. And when you are using software, so it's just click and go, so it's really easy. Yes, with software acquisition, it can be really weak because you can. It's easy to lie to a driver, etc., etc. But it's a cat and the mouse game. So what works in a way works in the other way. So if people release something to bypass something, you can still fix it, and etc. So it works in both ways. But the thing with the software acquisition is that this is present everywhere. So there are more and more machines using the virtualization. So to get a physical memory dump, it's way more easy because the virtualization is almost everywhere now. So the physical acquisition is only funny when you want to impress some people, but in real life, the software acquisition is more stable and more used. So as I said, the virtualization is used almost everywhere. Every hypervisor does have a suspend feature. So when you are pausing a virtual machine, the hypervisor is making a copy of the physical memory of the virtual machine on the host disk. You can also, on every hypervisor, does have to maintain a copy of the physical memory even when the virtual machine is running. So it means you can still access to the physical memory even if the virtual machine is running. In the case of VMware, they have the vmem file, which is really famous. This file doesn't have a very specific file format, so it's like a raw dump. So we will see in the next part that it's really easy to convert, unlike the Microsoft Hyper-V product, which use a very specific file format and compression. So in this talk, I'm only going to focus on the hibernation file, the Microsoft crash dump, on the raw memory snapshot. What you have to remember is that the hibernation file is compressed, even if it's really easy to generate because it's a feature present on every Windows operating system. To analyze it is still a challenge because it's compressed, and we will see later it has a lot of different file formats. And to get a Microsoft crash dump, actually, we only have the Bluescreen of diff way, but we will see with the tools I'm going to present that is no longer the case. And we can still generate a raw memory dump. So let's say you are using the DD executable and you try to read the device physical memory device. You will have a raw dump of the physical address space. So all these three memory images does have a different file format. Only the Microsoft crash dump is really easy to analyze because it has a specific file format, and Microsoft is providing a tool to analyze it. And everybody is using a Microsoft crash dump, as I said at the very beginning, especially people who are looking for bugs or kernel developer or kernel troubleshooters. So again, we are going to focus only on the three circles, the raw dump, the hibernation file, and the Microsoft crash dump. We will see how to get a Microsoft crash dump from either a raw dump or an hibernation file. So here is a flowchart of the physical address space. So in fact, in the physical address space, you don't only have the physical memory, you also have the address space used by a device. The physical memory is in fact only the blue blocks. this is what we are really interested in. This is where the user-land address space of every application on where the kernel address space is stored. So the blue blocks are what we are looking for on what we really want. This is what we can retrieve inside the Microsoft Hibernation file or in the Microsoft Crashdump file. So if you have this kind of physical address space, the red blocks will be never copied because they belong to the device memory. The problem with the Microsoft Hibernation file is that you have, at least from Windows Vista and below, you have a 4 gigabytes limitation. It's no longer the case with Windows 7. You can still use the hibernation feature even if you have more than 4 gigabytes of physical memory. And if you want to generate a full memory crash dump with the BSOD, if you have more than 2 gigabytes, you will only have a mini dump, which will be only 64K or 128K. So when you are doing a copy of raw memory dump, so it's exactly the same. It's exactly a copy of the physical address space. So there is nothing really complex here. When Windows is generating the Microsoft Crash Dump, Windows is taking only the 3 blocks, it put it in the Microsoft Crash Dump file, and it's adding the Microsoft Crash Dump header, which contains information which that Windows debugger is going to use to initialize the debugger. So, unlike the raw memory dump, the Microsoft Crash Dump has a format which is widely used. In this header, we can retrieve the most important information we need for the analysis that makes possible the analysis under Windows Debugger. Because when you have a raw memory dump, you have to firstly retrieve a lot of information and to brute force several addresses. The Microsoft Crash Dump is not compressed, which is not the case of the Microsoft Hibernation file, which is really more complex. So, like the Microsoft Crash Dump, it will only take the blue blocks and it will compress them in a 64 kilobytes block. It's also using a file format, but this one is only used by the process which will resume the operating system state. So, regarding the file format, the raw dump doesn't have any file format, so it doesn't contain information we could use to directly analyze it. And most of memory analysis tool only support this this kind of memory snapshot. But this one is very limited. We will see why. And the hibernation file contains a file format. So at the very beginning, we have the important information we will use to convert the hibernation file into a Microsoft Crash Dump. The problem with the hibernation file is that we have around 7 or 8 versions of this file, from Windows XP to Windows 7, and it depends on the architecture, but 8 version is not really a problem, at least for the tools I'm going to show. So with the Microsoft Crash Dump, so which is the topic of this talk, it had been used for several years by most of developers on people on Windows. Moreover, Microsoft is maintaining a free tool, which is called Windows Debugger. Windows Debugger has a notable advantage. It clouds the Microsoft symbols. So it means it works with every version of Windows, because you can retrieve the symbols remotely from the Microsoft server. So let's say actually there is the SP1, the beta version of the Service Pack 1 of Windows 7. Actually, there are no tools to analyze a memory dump from a Service Pack 1 of Windows 7. So let's say you are able to convert a Windows Hibernation file into a Microsoft Crash Dump file of a Windows 7 SP1. You will be able to load this file in Windows Debugger. And Windows Debugger will be able to retrieve the symbols from the Microsoft server, so you will be able to do the analysis and you won't be stuck. So the symbols does have a lot of advantages. On Windows Debugger does have a free SDK, so you can still develop your own plugins and everything. So here is the flowchart of the software memory acquisition on Windows. So by using Windows, you have two ways to generate a memory dump. But as we have seen, it has some limitation, especially for if we are using the Bluescreen of diff to generate Microsoft Crash Dump, because if you have more than 2 gigabytes of memory, you won't be able to have a full memory snapshot, which is the most interesting snapshot. Same thing with the hibernation file. Depending on the version of Windows, you won't be able to have an hibernation file if you have more than 5 gigabytes of memory. But if you are using third-party tools, most of the time you will be able to generate a raw memory dump, which is a raw memory dump that you could only be able to use with a very specific software. So again, you have a dependency regarding existing tools, which are not necessarily complete or are very new. With Win32DD and Win64DD, which is one of the tools I'm going to present, you can generate directly two kinds of memory dumps on a live system. So raw memory dump, like every existing tools, but also you will be able to generate a Microsoft Crash Dump directly without generating a Bluescreen of diff. So let's say you have a live machine, you want a Microsoft Crash Dump to analyze it, to analyze under Windows Debugger. Just run WinDD and generate a Microsoft Crash Dump, and that's it. And you don't have to reboot the machine. So the toolkit I'm presenting is called the Monsource Windows Memory Toolkit. So it contains various utilities, including WinDD, dump to bin to convert a Microsoft Crash Dump into a linear memory dump, the raw dump. You can also convert a raw dump into a Microsoft Crash Dump, so we will see why it can be interesting sometimes. There are also two tools for the Microsoft Hibernation file. The first one, Hiber2DMP, is going to convert directly a Microsoft Hibernation file into a Microsoft Crash Dump. And the second one is going to uncompress, Hiber2bin is going to uncompress the Windows Hibernation file. So regarding WinDD, so this is a physical memory acquisition utility for Windows, which you have to use on a live system. So it works from Windows XP to Windows 7 with both 32-bit and 64-bit edition. It supports two formats of output file. So the first one is the raw dump, and the second one is the Microsoft Crash Dump. And you can generate a Microsoft Crash Dump even if you are not using the debug mode, which can be really useful sometimes. So it means you don't have to reboot. And it also has hashing features, so you can At the same time you are generating your memory dump, you can have either an MD5 hash, SHA-1 or SHA-256. It also has 3 different mapping techniques which are present to don't be stuck. For instance, there are some memory software utilities to acquire the physical memory only using the device physical memory device. So if you are a rootkit, it's really easy to block. So that's why I put 3 different methods. If you remember the first image, we have different blocks in the physical memory. Windows is only taking care of the blue blocks, and if you use WinDD, you can choose if you want everything or a very specific blocks or not. So it's more complete than a Microsoft crash dump generated by Windows, for instance. And you don't have the 2 gigabytes limitation. For instance, if you have a machine with 8 gigabytes of physical memory, you can still run WinDD on it and to have your 8 gigabytes memory snapshot. WinDD also has a feature to send memory dump remotely over TCP/IP. So the TCP client is running in kernel mode. And you can also switch WinDD into a server if you want to receive the memory dump. It's not mandatory to use WinDD. You can, for instance, if you want to receive the memory dump on a Linux machine, you can still use Netcat because there is no specific header in the packet WinDD is sending remotely. It's really fast. You can also use a SIMB file system as a target path. Yep. Sorry? I don't listen. Oh, it's already public. I'm giving the address at the end of the talk to download it. And unlike LiveCADD, which can also generate a Microsoft crash dump if you want, at least with the last version, you don't need to use symbols to generate your Microsoft crash dump. So you can really use it in real life without any problems. So if you want to use it, if you want to use WinDD to send a Microsoft crash dump, it's really easy. You just have to type the following command. So you just have to specify the address of the remote server on /d. Yeah, means that you want a Microsoft crash dump. And that's all you have to do. So it's a really easy command to do a really complex job. So here is a screenshot of a remote acquisition of a memory dump. So as you can see, I'm really lazy, so I'm using localhost as a server. But still, this is what you can see when you are using WinDD. So as you can see in the right part of the screen, we have some memory statistic regarding the memory usage on the memory size, the physical address size, this kind of stuff. We can also have the hash of the memory dump. It tells us how long time it took to have the memory dump. And in the left part, we have the server part, which tells us that we have correctly received the memory dump and how long time it took to receive it. So again, when WinDD is sending the data to the server, it's done from kernel on, so it's really cool. And it's not using the, for instance, in Windows Vista, Microsoft introduced the WinSock, so it's not even using the WinSock. Yeah, so you can also use it locally, of course. So you have the same information I said before regarding the memory statistic. So it's pretty much the same thing, except you are acquiring your memory dump on your local hard drive or USB stick. dump to bin is another utility from the toolkit. So again, the usage is really easy to understand. You give a file as an input and it will give you the output. So dump to bin will reconstruct the physical address space from a Microsoft crash dump. It will also give you an hash. It works with both x86 and x64 Microsoft full memory crash dump. So here is what we see when we are using the dump to bin utility. So as you can see, it's really a basic output because it's only reconstructing the physical address space from the memory dump. Bin to DMP is way more funny because it will convert a copy of a physical address space, or let's say a linear memory dump, that you can retrieve by using, for instance, a software acquisition tool like MDD, or a snapshot of a virtual machine, of a VMware virtual machine, with the vmem files. There is one thing which is really cool. When you are running a virtual machine with VMware, the vmem file is created at the same time. And with bin to DMP, you can still open this file even if the virtual machine is running. So you can convert the live activity, the live physical memory of the virtual machine into a Microsoft crash dump. So even you don't even have to stop the VMware virtual machine. So it's really useful when we are doing, for instance, malware analysis, or if you want to check some things regarding the behavior of your virtual machine. And again, this one works with x86, so the 32-bit edition of Windows, and also with the x64 edition from Windows XP to Windows 7. So, and as I said, it works with VMware virtual machines also. So, unlike the previous screenshot, here you can see that there is a structure which is modified. In fact, this is the context structure from the KPCR, because if we don't modify this structure, at least, or if we don't check if the structure is correctly filled, when you will try to read the Microsoft crash dump in WinDBG will think that you are in 16-bit mode and you won't be able to use all WinDBG commands. So by doing this, we have a Microsoft crash dump which is at 100% usable by WinDBG. So now we have the interesting utilities regarding the Windows hibernation file, which is mainly used for forensic purpose. So this one will convert the hibernation file directly into a Microsoft crash dump, and it will work with every version of the hibernation file from Windows XP to Windows 7. And you will have Microsoft crash dump. So let's say you have your Windows hibernation file of Windows 7 SP1, which is still a beta. You will still be able to analyze it, which is really a challenge for the forensic scene. So here is what you see when you try to convert an hibernation file into a Microsoft crash dump. So here I will try to convert the Windows 7 64-bit hibernation file. So, as you can see, if you remember the flowchart of the hibernation file, there are a lot of compressed block, so it has a lot of entries. So firstly, the tool has to sort every entry. In this case, it's pretty long because it's a really big file. It's like, I think it's a 4 gigabytes hibernation file. So it will take around 30 seconds or so, yeah, 25. Yeah, and it's fixing the KPCR structure to make it at 100% usable by Windows Debugger. So, and again, it's a really big file, so it takes some time. So we will switch back to the slide in the meantime. So again, it provides also an MD5 hash of the generated Microsoft Crash Dump. The last one is not exactly the same one. It's still regarding the Windows hibernation file, but this time it will uncompress every compressed block of the file from the memory. So again, it's really easy command to run. It works with every version of Windows, from Windows XP to Windows 7, with both x86 and x64 editions. It's almost done. Can you take the mic, please, because I don't hear anything.
I just had a question about converting the hyperfill to
DMP?
To the dump file. Yeah, or not a crash dump, to a just a RAM dump, a bin file, I guess you call it. I've used volatility to try to do that before, but I frequently have some failures. And I did some research into it. I was told it's because they often have this hex 0 string of padding in the beginning, and I was wondering if you're familiar with that, or if you were able to get...
Yeah, sure, because in fact, in 2008, I published a paper at Blackhat US to explain the structure of the hibernation file, and that by using this research that volatility had been able to use the Windows hibernation file. So regarding the first page, when it's filled with null byte, when you use hyper2dmp or hyper2bin, even if the first page is null, it will work. So you don't even have to have a valid Windows hibernation file. So it's a really good question. Let's say a laptop had been used the hibernation feature. So this laptop is resuming the system. So it's rebooting several times, but the user is not using the hibernation feature anymore. The hibernation file will be still present on the disk. On the first page will be filled with null bytes. And if you use the hyper2dmp or hyper2bin utility, you will still be able to convert it. There is also one thing with volatility. Actually, it only works with Windows XP SP2 and Windows XP SP3, if I remember correctly. In this case, as you can see, it's a Windows 7 64-bit edition, hibernation file. So, yeah. I'm not really stuck by this, but if I use WinDBG, Yeah, as you can see, I can still load the Microsoft Crash Dump in WinDBG, and it works perfectly by using the symbols. So it doesn't have the limitation volatility has. So, and as I said, for instance, if there is a Windows 7 SP1, so it's not even a finished release yet, so you can still do the same thing. So instead of rewriting something from scratch, which is not necessarily a good idea if you cannot improve what already exists, I just use something which already exists, which is the Microsoft Crash Dump format. And I use WinDBG, and it does the job correctly. And for people who like to have a command line, there are people like this. In WinDBG, you have a command line, you have a graphical interface, so it's really complete. And as I said, it's maintained by Microsoft for a long time now. So that's fine, that's perfect. That's why the task is called the Bluescreen of diff is dead, because before we had only the BSOD to generate a Microsoft Crash Dump. And with this toolkit, you can generate a Microsoft Crash Dump from any Windows memory image. Did I answer to your question? Okay, perfect. So, Iber to bin, let's say you have a Windows XP, SP2, Windows hibernation file. You can uncompress the hibernation file, even if the first page is null. And if you like volatility, you can analyze your linear memory dump with volatility. So this is what people call the interoperability. So you can still use your favorite tools. And it works like the Iber2DMP. It works with every version of Windows, from Windows XP to Windows 7, and with 64-bit and 32-bit edition. Not 64-bit, but x64. So the interface is pretty much the same. Again, it feels, it's only uncompressing, so this time it doesn't feel the context structure from the KPCR. So again, regarding Windows DBG, it's maintained by Microsoft for several years now. So it's a free tool. It's used by a lot of people doing several kind of jobs, like the developers, troubleshooters, bug hunters, whatever. It had been designed for crash dump analysis, but also for debugging userland application or kernel on driver. So, as I said, you have a graphical interface. It's a really complete tool. Before, when you wanted to download WinDBG, you had a direct link to download it. But now it's only present inside the Windows SDK or the Windows WDK. So you have to download the full SDK of Windows. So here is a screenshot. So this is what we have here. So again, it's perfectly compatible with WinDBG, so you can access to every WinDBG command. If you look at the help, so I really like a lot of commands. So it's really complete. So it's a really good thing to have Microsoft Crash Dumps. You can also use a script. So, for instance, with this command line, you will retrieve the every process. But of course, you already have a present command to do this. This is just to say that it's really complete. That if you want to, you can also write plugins for WinDBG if you want. So it's really complete. So as a conclusion, you don't need anymore to the Bluescreen of diff to generate a Microsoft Crash Dump, and especially converting a Windows hibernation file into Microsoft Crash Dump, or to have a VMware, a virtual machine, physical memory to convert into Microsoft Crash Dump is really a useful thing. So, to reply to the question you asked me, if you want to download the tool, you just have to go to this address, and you will be able to have the toolkit with every utilities. The next step is to take a look at every virtualization products, like Hyper-V, which also has its own state of physical memory. So again, we will be able to use WinDBG to take a look at virtual machines memory. So, do you have any questions? Okay, cool. So now you can come to me and pay me beers. Okay, thanks.